Okay, so here we're asked to find the angle between two vectors. And the first vector is 4, -3, and the second vector is 3, 8. So let's put this on a grid real fast, just to see what we're looking at, so we can get a better idea maybe of what we have here. So 4, -3 is the vector that goes from the origin to here. So there's 4, -3. In fact, let me color code it. So this one is going to be blue. There's a vector 4, -3. Then we have the vector 3, 8, which is 3 right and 8 up. 3, 4, 5, 6, 7, 8. There we go. Way up here. Now, the length of these don't really matter as far as the angle goes. It's not like the longer the vector, the bigger the angle. But what we are looking for is this measure of the angle here. What is the measure in between these two vectors? So at what angle are they both behaving at? Okay, so to do that, we need to find three things. So that angle is found by taking the inverse cosine of two things. Number one, the dot product of these two vectors. So one's u and one's v. It doesn't really matter which one is which. So we take the dot product in the numerator, and then we find the magnitude of the first vector and multiply it by the magnitude of the second vector. Okay, so magnitude just means length. So there are three things that we have to find. First, we have to find the dot product, and we have to find the magnitude of both vectors. So just for fun, let's call the first one u. So this is the vector u. So here's u. And this one will be the vector v. But because dot product is commutative, it really doesn't matter which one we call what. So let's find u. First of all, we're going to find the magnitude. Actually, we're going to do v because that's my color. So the magnitude of v is found by taking the square root. Basically, we're doing some Pythagoras. It's a Pythagorean theorem of 3 squared plus 8 squared. Okay, because we have a right triangle where this side is 3 and this side is 8, and we're basically looking for the hypotenuse. So 9 and 64 is the square root of 73. So that's the length of v. Sure, you can decimalize it if you want to, but I'm just going to save myself some button pressing and not do it. So now let's find the magnitude of vector u. Once again, we're going to use the Pythagorean theorem. Okay, here we have a y value of 3 and an x value of 4. So 4 squared plus 3 squared is the square root of 25, which in this case is a nice perfect one, so that's just the number 5. So if this 73 would have been nice, we would have done it too. So now that we have u, we have that magnitude, and we have the magnitude of v, now we simply have to find the dot product. So the dot product is found by taking the product of the x things. So 4 and 3 are the x, the horizontal components of each of these vectors. So 4 from here and 3 from here. So you multiply the x components together, plus we're going to multiply the y components together. So -3 times 8. Okay, so we do the product of the x's plus the product of the y's, and that number is the dot product. So 12 minus 24 is a -12 dot product. Okay, so now I have all of the information that I need. So I can plug it into here. Inverse cosine of -12 was the dot product. V had a magnitude of 5, and u, or switch them, whatever they happen to have been, was root 73. So I'm going to put all this into my calculator now, and it's going to give me an angle between 0 and 180 degrees. And that's going to be the angle in between these two vectors. So let's see. Calculator says inverse cosine of fraction -12, 5 times the square root of 73. Enter. That gives me an angle of 106.3 degrees. Okay, so let's go back at our picture. Yes, it does in fact look like that's bigger than 90 potentially. So I'm going to go ahead and trust that that's the right angle. My calculator told me something good. So we need to find the dot product, the magnitude of both of your vectors, and then use the inverse cosine in order to find the angle between any two vectors.